Hi class, I want to go over how to use the calculator functions BinomialPDF and BinomCDF for solving binomial probabilities. And we're going to look at an example. The example says 45% of consumers say it is important that the clothing they buy is made without child labor. You randomly select 17 consumers. Find the probability that the number of consumers who say it is important that the clothing they buy is made without child labor is part A, exactly 5, part B, at least 11, part C, less than 12. Notice this is a binomial experiment. The number of trials is n equals 17, since we were told we had 17 consumers. The probability of success is 0.45, since we're told 45% of consumers say it is important that the clothing they buy is made without child labor. To answer part A, we could use the formula to find the probability of getting exactly R successes, in this case, exactly 5 successes. This formula would give us that probability, but we don't have to use this formula, since there's an easier way to find these probabilities using the TI-84 calculator functions. We have the BinomialPDF and the BinomCDF functions. So for part A, we can use the BinomialPDF function, since it finds the probability of exactly R successes out of n trials, just like the formula. We only need to enter in n, p, and r into the BinomialPDF function on the TI-84. Let me show you on my calculator how to do that. So you'll go to second distribution, go down to BinomialPDF, enter in the number of trials. In this case, it was 17. The probability of success is 0.45. And we're looking for exactly 5 successes. I'm going to hit paste, enter, and there we see the answer is 0.087. So again, you can use BinomialPDF to find exactly 5 successes. In this case, 5 successes. Anytime it says exactly R successes, you can use the BinomialPDF function. Let's go on to part B now. We want to find the probability of at least 11 successes. Well, the BinomCDF function on the TI-84 finds the probability of less than or equal to R successes. So we can use the BinomCDF function on the TI-84 for a statement that is the probability that X is less than or equal to R successes. This wording for part B, the probability that X is at least 11, is a greater than or equal to statement. So the BinomCDF function does not calculate greater than or equal to statements. Instead, as a workaround, we can use the concept of a complement to calculate this probability. Remember that all probabilities in a probability distribution must add to 1. The complement of X is greater than or equal to 11 is X is less than or equal to 10. And the probability that X is greater than or equal to 11 plus the probability that x is less than or equal to 10 will equal 1 for 100%. So when you add a probability and its complement, it will equal 1. So we can find this probability using the calculator very easily if we subtract the complement of our probability from 1. So we would, in the calculator, put in 1 minus the probability that x is less than or equal to 10. The binomial CDF function will calculate a less than or equal to statement easily. So let's do this on the calculator. So you can just go ahead and put in 1 minus, and then go get the binomial CDF function. And we'll put in the number of trials is 17. The probability of success is 0.45. And we saw that the complement of at least 11 is less than or equal to 10. So then put paste, enter, enter again, and we see that the answer is 0.083 if we round to 3 decimal places. So again, if you have a greater than or equal to statement, we can use the binomial CDF function by subtracting its complement from 1. All right, let's go on to part C. Part C asks for less than 12 successes. The binomial CDF function on the TI-84 finds the probability of less than or equal to R successes. So the binomial CDF function does not calculate strictly less than statements. Since the binomial distribution is a discrete distribution, we know that the probability that x is less than 12 is the same as the probability that x is less than or equal to 11. So we can use the binomial CDF function directly to calculate the probability that x is less than or equal to 11. So let's take a look at how to do that on the calculator. Second, distribution, binomial CDF, number of trials is 17, probability of success is 0.45, and we want the probability that x is less than or equal to 11. Whatever goes here will be included in that statement, less than or equal to. Enter, enter again. And if we round to 3 places, we would get 0.970. Okay, so here we've seen how to use the calculator to find these probabilities. We could have used the formula, but we don't have to, since there's an easier way to find these probabilities using the TI-84 calculator functions. To summarize, the binomial PDF function calculates the probability that x is equal to R. So for statements that say exactly R successes, and the binomial CDF function calculates the probability that x is less than or equal to R successes. You have now learned how to find binomial probabilities using the TI-84 functions BinomPDF and BinomCDF. Good luck, everyone.